Hello, my name is Blake Perkins, and this is my project about related rates. I can see my house from here. So the problem is, an airplane is flying at a rate of 625 miles per hour. When it passes over the control tower, the airplane is at an elevation of 9,862 miles high. How fast is the distance between the tower and the plane changing when the plane has flew 15,089 miles past the control tower? Here we have a model of a problem. This is the plane, and it's the control tower. This distance right here, which is y, is the elevation of the plane. It is never changing and is always 9,862 miles. As the plane moves at a rate of 625, it will keep moving along the x-axis. And that explains the distance. So we said it flew at a distance of 15,889 when we're trying to find the distance of z. And z is the distance between the control tower and the plane. Here we have a representation of a model on paper. So we have the plane, we got the control tower, and you can see it's going to move along the x-axis. The y is forever going to be the same, and we're trying to find z, the distance between them. So using the model and the problem, we know that dx dt, which is the rate of the plane, is always going to be 625. The y, which is the elevation, is going to be 9,862. We're trying to find the rate or change in dz dt, and we know that x is 15,089 at that given moment. The next step is the Pythagorean theorem. This is because we know y. If we know x at the given moment, we do not know z. We need z for this problem to be able to solve it. So what we do first is we plug in y, which is what we know. Then we plug in our x, which is at the given moment. You square them and add them, and you get your number. And then you have to make sure that you take the square root of them so you can find z. So for this problem, z is about 18,026 at the moment x equals 15,089. Lastly, we now can take derivatives, since now we know all the info for this problem. We're going to use the formula of Pythagorean theorem of x squared plus y squared equals z squared. You can see that here, and we're going to plug in 9,862, which is the y, which is given. So you get x squared, that turns into 2x dx dt. The y, since now it's a number, turns into 0. And z squared turns into 2z dz dt. We then plug in all the info we have. So we plug in our x, the dx dt, and the z. We do not know dz dt, and that's what we're going to solve for. So this whole area here turns into this big number, and then 2 times 18,026 turns into this. Now we need to get dz dt by itself. So we're going to divide this number by 36,052 to get dz dt by itself. In the end, dz dt equals about 523.2 miles. So that's the change in rate of z, or the distance between the control tower and the plane. I hope this problem helped you guys, and that you understand related rates better now. Have a good day.